like trick or treating, and
right.
like kind of like a couple costume thing. My mom always picks it out for us.
Aw.
It was Slender Man this year.
Yeah, Sean.
Yeah,
You got pranked, boy. Thought I was mad at you, though, buddy.
You might really not say how that video didn't make any sense.
What time is it? Is my video uploaded? If my video uploaded, it's past 10 o'clock.
I know, I'm checking. Oh, yep, it is. I got a notification. See, like, news from second to relook at Steve.
Boom.
Not according to plan. What wasn't according to plan?
We didn't even win a single match.
That happened.
And then I said, like, we're gonna win the match. Also, that little blur right there.
What about me?
Oh, you got one light. You probably like your own video.
Man, videos, man. Look at that little dude.
Oh, there's that old weekend.
Person that gets thrown on blackout.
Yeah.
And then he used like an auto rifle to kill him.
Yeah.
A
BMP.
Hellstorms.
He brought it in first with the R60. Hey,
It was so like, I have no idea what was going on.
He brought the freaking R60 first. This guy cheats at everything.
Okay. Alright, hey, take a seat.
Oh.
Okay, we have a couple different topics to talk about today. Our main goal is to talk about proportions. Section 3.2 still. The homework, page 61, 62,001, we got on Friday last week. That is due tomorrow, so you'll have some time after lunch day where you can kind of work on that, but not a lot of time. Questions?
I won't be here.
Friday this week. Okay, all right, this will be fun. So, whatever you get, just check online. The video will be there. If we have homework, I don't know. We'll see. We'll kind of touch base. All right, the section we're in. Obviously, we're in the section 3.2. We're going to continue this today. We're going to talk about the main purpose of proportions today. Now, we've done homework, and you guys know all the little basics about it, but we haven't really discussed the uses of it yet, like a major part of the uses. We've talked about real, like, intro stuff. So today, I'm going to really be testing your knowledge on can you solve a proportion, and then we're going to talk about the uses of it. So the number one thing we're going to be talking about, obviously some basic uses. Automotive. That's going to be one of the things we're going to talk about. Automotives. We're going to talk about some type of baking. Okay? And then we're going to talk about the last topic we're going to talk about, which we're going to spend pretty much the most time on, is travel. That's what we're going to spend a lot of the time on today. So that's going to be our main goal. So we're going to just do a bunch of examples today of these, see how well you can do. You definitely need a calculator today. So as I'm putting some problems on the board, you can actually test it out. So we'll hand out some calculators here in a second. But let's do a quick review on how proportions look. So let's start with that first. What is a proportion? What do you guys remember from last week? What was the definition of a proportion? What was the definition of a proportion?
The comparison of two fractions using an equal symbol.
Yeah. So the idea of a proportion, it's using two fractions, something like this. Something like that. Maybe I should make this a different. Let's make this. Let's make this. Right. So it's solving a proportion where you're saying two fractions equal to each other because you use an equality symbol. And what we do on a proportion is you solve for a missing term. So that's kind of the idea. We're finding missing terms today. And that's what we're doing. So how we do that? There's a bunch of different methods for how we solve proportions from Friday. But the number one that we use is cross products. Okay. Now, if you don't remember what a cross product is, it's cross, multiply, and divide. It's the goldfish method. It's the correct term called cross product, right? That's what we talked about last week. The second method we discussed, I believe it was like last Tuesday, we talked about scalar multiplication. Okay, so here's the idea, how we can actually solve. Let's talk about scalar multiplication first. So we're going to start on the side with the x, and we're gonna look at where the number's at. So we're over here. The x is on the top. So what did they do to the 4 to make it a 16? What did they multiply or divide by? Did they multiply or divide by something to make it to the other number? What do we do here? We multiply by what? What do you take times 4 to make 16? You took it times 4. Does that make sense? Okay. So on the top, this is the same thing. They took some random number. This is an unknown number, right? Sometimes the book did this. This is what your homework kind of looked like. They just left a blob up there. And they said, okay, what number did they take times 4 to make 8? Because whatever they multiplied on the bottom, you have to multiply on the top. So what number do you take times 4 to make 8? 2. That's this number. You just solved it. That's using scalar multiplication. Okay, like you're finding the number that fits that same pattern. They took the bottom times 4, they took the top times 4, and it would be 8. Now that's really simple. Now some people, when they do these types of problems, they don't go that direction. What they do is they start on the side without the unknown. So they start over here, the side without the variable, and they work their way backwards. Okay, what do they do to 16 divided by 4, right? 16 divided by 4 is 4. 8 divided by 4 is the number 2. That's how some people solve it. It's still a scalar. There's some scale there that they use top and bottom. That works almost every time. The problem is, what happens when it makes weird decimals? So what we use on that case, we use a cross product. This is that goldfish method. So whatever your term is, let's say this is 100 here, and this is 80, let's say, that type of thing. So what you do in the scalar on the cross product, because sometimes people can't see what they did here. You start with the number above or below your x. So I start with a 5 here. So the number I'm going to start with is above or below the x. You cross multiply, and whatever that answer is, you divide by the last number. So I'm going to take 5 times the 80. That's cross multiplying. And whatever that answer is, you divide by the remaining number. And this will give you that unknown, the x. That was the goldfish, because what happens when you do this correctly, it literally looks like a goldfish. Okay, that's the idea. It looks like a goldfish. So cross multiply and divide, and it gives your answer, and your answer should be something like 4 or something like that. The answer 5 times 80 is 400, and then divide by 100 gives you the answer 4 on a calculator. So double check on a calculator. 5 times 80 divided by 100. Check it out and see if it works. Okay. But again, that's how all proportions work. Okay, cross multiply and divide. This is the cross product method, which is this method, works every time. It'll even give you when your answers are weird decimals. It works every single time. Okay, so now that we get the strategies down, we're kind of reviewing what we did last week, because that was like half of your homework right there. I want to talk about how do we use it, the uses of it. So one of the examples, I think I hinted at on Friday. I think I hinted at Friday, or maybe it was Tuesday. I don't remember what day of the week it was last week. Where if you had a car, so here's, I'm going to use a truck. Okay, here's my truck. Done. I have little tires on it, and I'm going to upgrade the tire size. So here's my little truck again, but now I'm introducing bigger tires to the thing. What we talked about last week was, if you don't take it to a mechanic, technically you'll probably be breaking the law, because you'll be speeding and you won't know it. Because how this works, there's a little OBD port on a car that you can calibrate certain settings on your car if you have the actual machine that works it. So the idea is, imagine that I had a truck with 13-inch tires, 13-inch rims, really kind of smaller tires. It's a small truck, and I was going down the road at 55 miles per hour. Okay. What happens when I upgrade to big 22-inch rims? Well, the idea is that even though the speedometer will be telling me I'm going 55, you'll be going way faster unless you get it calibrated, because the computer won't know any better. And I'm going to show you that example. This is where I think we got cut off. I think it was last Friday when I did this. The idea, how does this work? Okay, so if we're going to solve this proportion without fixing the OBD port on the computer inside the car, can somebody do the proportion here and figure out how fast would I actually be going? 93 point what?
0.07.
Okay, that's fine. Okay, miles per hour. So again, how we do this? You start with the number below the x, so I'm starting with 20, cross multiply, and then divide by the 13, and it gives you your speed. This is how fast technically you'd be going if you didn't get the computer fixed and your speedometer said 55, even though you have the new tires in your truck. Okay, you see that you're most definitely speeding. Okay, so it's a big deal. Now, why are you going faster? Because the car is programmed to turn the wheels so many times per hour. That's all it knows. So let me give you an example here. Okay. Got a basketball here. Got a little tire. So let's say this is my original tire. Okay, and we're going to use the little triangle or the little box here at the top. Okay, and I'll use my basketball. And use a little NBA, there's the actual dot on the basketball. Okay, so this is my original tire. All I'm going to do is, so the car is programmed to turn this wheel so many times per hour. So let's say that I went so many feet, and so the car said I'm going one particular turn. So the car is programmed to turn my wheel once. So I hit the gas a little bit. And so I'm gonna rotate this car tire exactly. Start here again, and I'm gonna rotate it exactly once. So I'm going all the way down and all the way back up until that thing's at the top. So there you go. So I started right where the basketball was. Started right here, and I rotated the car, and it finished there. So whatever speed it said on your car, maybe you're going 1 mile an hour. So that's how it knows to turn your car tire exactly that many times per hour to get me to that 1 mile in that 1 hour. Okay? I'm going to do the same thing. So I upgraded my car tire without changing the computer. So the computer just knows, okay, I need to rotate this tire once. So it starts here, right at this line. So I'm going to rotate the tire once, and I'm going to stop when the needle, that little hole, comes back to the top. Okay, so I'm going to rotate it once, and boom. So this is where it stopped. So the new tire got to here. I didn't fix the computer. It rotated my tire once, because that's what it was programmed for the smaller tire. Okay, you see that on the board I traveled a farther distance in that hour. That's why you're going faster. You're going more miles per hour. That's the concept here. Okay, so that's why you got to fix the port, because what should have happened when you first started with your car tire, it should recalibrate so it knows, okay, this is a bigger tire. I only need to rotate it maybe half and then stop. And now I'm traveling the same distance, the same miles per hour. So it knows it reprograms how many times it needs to turn that car tire. That's all it's doing. Okay, so that's the concept. So a lot of people don't realize that. Now that's it. That can work for anything. It doesn't matter the object. It can work for any concept. But I use cars because it makes a lot of sense. Here's the part where it fails. It doesn't work for time. It does not work for time, especially like in travel. So let me give you the example here. So imagine we're going to Mason City. Okay. So we're traveling to Mason City, and let's say normally to get from here to Mason City, what does it take? 35 minutes? 35 minutes? Okay, so 35 minutes to get to Mason City, and that's traveling 55 miles per hour. Okay? Makes sense? But let's say I'm running late today. Let's say I got to get to Mason City. Okay? So I only have 20 minutes to get there. So what is your logic telling you? How fast do I need to go? Don't use your technical. What is the logic? I better go fast, right? I need to go like incredibly fast to get there because I'm already late. So I need to go faster than 55 miles an hour, which you don't want to do. Just accept being late. But I'm late, right? Now do the math here. See what this thing is going to tell you. How fast do I need to go to get there in 20 minutes? Say it again?
It says 31.
Yeah. 31 miles per hour. Is that what everyone's kind of getting? Your calculator's not wrong. This math problem is wrong. Proportions don't work for time. it doesn't work. It's completely broken. Because the idea is that how proportions work. I went from a bigger number to a smaller number on the top, agreed? So how a proportion works, it'll do the same for the bottom. Whatever this number is, it will make it smaller, because that's how it works for the top. If the top gets smaller, the bottom will get smaller. This number doesn't make any sense for time. You should be going like, in theory, you should be going like 70 miles an hour to get there in 20 minutes, okay? So this number doesn't make sense. So it doesn't work for time. It fails at that. It's really bad at time. It's also really bad for temperature. So instead of time, temperature also fails. So here's an example that I just did last night. So on this pizza I was cooking, the pizza cooks at 425 degrees for this frozen pizza, and it takes about 11 minutes to cook there. Okay, so that was my frozen pizza I had. But let's say I'm going home for lunch and I only have 5 minutes to cook that pizza. I don't have 11 minutes. I have 5 minutes. I have to cook it, get it out of the oven, and take it with me wherever I'm going. Right? So how hot does the oven need to be? Don't do the math on the calculator. Just common sense. I have 5 minutes to cook this pizza. So what are you thinking? Like super hot, right? I have to like crank up the oven. Don't do that. By the way, it's super unsafe. But if you actually do the math here with your calculator, it will not tell you that. So do the math right now. So do the math. Cross, multiply, and divide. So you're starting with the number above or below my x, cross, multiply, and divide by the remaining number. What does it tell you? 193. Say it again? 193 degrees. In 5 minutes, it's going to be doughy. It's not even going to be cooked. You know, that cheese could be potentially still frozen, okay, for 5 minutes at 193. Now, the reason why this is failing, like you're wondering, like, well, why isn't it working? It should be telling me like 600 degrees. Because again, it's that same concept that happened with time, that, or the actual like miles per hour there, that how proportions work.
Greg Jurdy, please come to the office. Greg Jurdy.
How proportions work is if the top or bottom number, if it gets smaller, right, 11 to 5, then the top number gets smaller. It's the same concept. It's linear, right? This is why that's the whole concept here. Proportions are perfectly straight lines. So if this one gets smaller, the top one gets smaller by the same fraction. Okay, so let me show you this concept of time and cars and temperature. So that way maybe like visually you can wrap your head around why this is not working right now. So I'm going to do it with the temperature for cooking. We'll start with that. Okay, how temperature works when you cook. It works like this. It's a curve. So the longer you put it in the oven, this is time, the longer it's in the oven, the actual temperature will increase like this. It increases by a curve. That's why like when you throw a steak on a grill, the first few minutes, it's still frozen. And then once it breaks that frozen point, now the meat gets really hot really quick. And so it actually starts cooking. They always say like when you're grilling food or you're cooking like pizza, that what you want to do is you want to leave it in the grill or the oven untouched for as long as possible. You don't want to open the oven. You don't want to open the grill. You want to leave the lid down and trust that it's going to work. Okay? And it's actually like the last 5 minutes that makes the difference, like when it finishes. The last 5 minutes, when it gets from not done to done. That type of thing. And you just pull it out accordingly. Because that's how temperature works. It slowly builds until it gets there. Well, that's the same with a car. When you hit the accelerator of a car, like when you hit the gas pedal on a car, does it go from 0 to 100 miles an hour instantly? No, it builds. Yeah, it might force you back into the seat a little bit, but it's actually doing this. It's building up speed slowly. Okay, because it's feeding gas to the lines, and it's actually processing, the combustion engine is actually working, and it will force the cylinders to turn, and then your wheels will actually spin. But it's doing it slowly. Now, obviously, some cars go a lot faster than that, but it's a curve. It's not straight lines. Okay, that's why the idea with the car tire and that going to Mason City didn't work, because the idea is that you want to get to some point in 10 minutes versus 30 minutes you're going a slower speed than when you took 30 minutes. That's the idea. That's why the math didn't work out for this, because how proportions work, this is based on straight lines. Is there some relationship between where you started to where you ended? That's why the car tire changing the size of the tire is perfect. If the tire changes, your speed changes perfectly in the same relationship. For how baking works, because there is a way to do proportions for baking. It's actually just the recipe. It's not the temperature of the oven or the time it takes to get done. It's the amount of ingredients you need. So let's say, like, on your recipe, it calls for 2 sticks of butter. 2 sticks of butter. And that makes maybe 35 cookies, right, with 2 sticks of butter, right? Well, what you can do is, if you don't need to make 35 cookies, maybe you need to make 135 cookies. What this proportion will do is it will tell you how much butter you need. That does work. You need more butter, because it's a perfect line. It's not temperature. Temperature is a curve. It builds. Same with the speed of a car and time. It curves. This actually works. So if you do the math, how many sticks of butter will I need? Cross multiply divide. So start with the number above the question mark, cross multiply, and then divide by the last number. What does it tell me?
7 point, yeah, just 7.
The 7? So 7 sticks of butter. That's what I'll need. You can use this for scale. That's how they do it for the cooks here. They have simple recipe books, and what they'll do is they know that, okay, instead of making 35 cookies, because that's what this recipe calls for, I need to make it for 100 kids. So they just ramp it up. Okay, I'll need this many sticks of butter. Or they'll change it and they'll go, okay, instead of 2 sticks of butter, maybe I need 4 cups of flour. That type of thing. So 4 cups of flour. So now this thing will solve for the flour itself. So now I cross multiply and divide, and it will ramp up. And they can do it for everything. Every single number will work out the exact same way. So you can figure out the cups, you can figure out the vanilla, you can figure out the butter, and you can just keep baking, and you just keep sticking in the oven, and all of this recipe, you can scale it up to whatever size, because it's perfectly in a straight line. Or if you need more, you have to use more. That's the idea. Okay? All right, is there any questions with how proportions work? All right, now, we're going to be going to lunch here in a little bit. What we're going to do after lunch is I'm going to show you how proportions work, what we're going to do for traveling, not time to get somewhere. What I'm talking about is distance you travel to get somewhere. That's what we're going to talk about, because I do want to show you how we can use this stuff, where it's actually useful. Okay, any questions with any of the concepts we used today? So it doesn't work for temperature, doesn't work for speed, or for time or temperature. Okay, so we'll be going to lunch here in a little bit.
Mr. Order, you'd be a good YouTuber.
What was that?
You'd be a good YouTuber, to be honest.
Yeah, so I kind of want to do that. Post some ideas online. Let's go. Cool. Complete vote.
Well, we just had a roasting battle.
Plus, PS3 don't even take online anymore.
Okay, hey, we're going to finish up some notes here, and then give you a little bit of time if you need to finish up page 61 and 62.
Take that, Xbox.
I wrote it.
Yeah. You can see how bad he wanted to say that. He was just walking.
You look so weird. He's like, boom, boom. Oh, cool. Okay.
Dylan's trying to tell us that Xbox is better than PlayStation.
Alright.
Let it all out. Let it all out.
Here, I'll give you something.
I don't want to be there.
What's up, Pete?
You did beat me yesterday. You used the PC.
Okay, hey, let's finish up some notes here on this topic, and then I'll give you a little bit of time at the very end where you can kind of work on your page 61, 62, if you still have not finished that. Remember, it's due tomorrow. All right, so what we were talking about before lunch, we were talking about, proportions and how to solve them, cross products versus scalar multiples, and we talked about, how it can adjust for like a recipe to make a batch of like more cookies. So if you notice from that picture over there, the big thing I'm trying to get you to understand is when you're doing this, that number one, the numbers across from each other kind of tell you what's going to happen. So like 35 to 135, this number got bigger. So the bottom number should get bigger. And not by, like, you're not adding or subtracting, you're multiplying. So that's why it's not going to be like 104 over here. It's whatever this cross multiplies and divides into. So that's what we're talking about. And the big thing is the labels are the same. So cookies are on the top, cups of flour on the bottom, or maybe sticks of butter, sticks of butter, sticks of butter. So that's the idea, that the labels are straight across from each other. Now, how we can use this in a different way I was talking about traveling. So that's what I want to discuss. I want to talk about how can we use proportions with a map. And this is kind of an old school way of doing it. Nowadays, you guys have so much technology with your cell phones and stuff that we can do this completely different. But I do want to kind of show you how this works. Okay, so let me pop this up here so you can see this. All right, what you're looking at right now, this is a picture of the United States from quite a while ago. I think this is a 2001 picture of the major cities in the U.S. Major cities in the U.S. So we can zoom in and we can kind of look at this. Now, why this is important? We can do a proportion for this problem. So I know it's very hard. It's a little blurry, but like right now, Iowa's right here, so this is Waterloo. Okay, so this is a major U.S. map. So here's Iowa, Waterloo. We have Des Moines. I don't even know what that city is. Davenport. Davenport. Jesus. Other cities, California has a ton. Texas, the main ones. Austin, San Antonio, San Angelo, Amarillo, Dallas, Fort Worth, that type of thing. So you can kind of get a glimpse for how this works. The one that always messes with people is Washington, D.C., that capital, right? Washington, D.C. is the District of Columbia. This is the capital of the United States. It's not Washington State. I don't know why people they cannot wrap their head around that. Washington, D.C. is actually like it's its own little district in the middle of Maryland. It has its own zip code. It's literally not a state. It's just it's a governing body. They have their own tax laws there. It's very different. So when you go to that city, it's completely different than any other place you've ever been. So, but this is kind of just major U.S. Now, how this works for proportions is if you look down in the corner on maps, especially like old atlases, they have a key down in the corner. Key is like a sense of scale. It's actually helping you set up proportions. So now, how I stumbled into this, why I know this, is other than just math, is my father was a semi-truck driver. So what he would do is he could guesstimate distances between cities. They didn't have the cell phones back then. This is 80s and 90s, They may have had GPSs, but they were super expensive, and he just took major roads to get where he needed to go. And so what he would do on Sunday nights is he would guesstimate, how far travel is going to be, how much fuel he's going to need, how long it's going to take him to get there. He would do all these things on a Sunday night so that he can figure out, okay, I know I'm going to have to make at least 3 gas stops. and how much that's going to cost him, so he knows how much money to have on him when he's actually traveling. It was just one of those things that, for him, for his business, that's what he calculated. Well, so here's the idea. So what you do is you use the scale. So you use the scale in the corner, and what you do is you use a ruler and you actually measure it. So, like if I put my ruler down here, and this says 400 miles, that is 7 inches exactly on this map. So that's this stick right here. So it's 0 to 7 inches. That's 400 miles. Okay. So that would be my. It's actually 300 miles. 300 miles is that stick. So 7 inches on this map is 300 miles. Now this is not accurate. If you want to get really accurate, what you do is you type in Google nowadays. You type in, like San Francisco, which is right about here, and you type in distance to Washington, D.C., and it'll give you that number. It'll say, like, that's 2,400 miles, 2,413 miles. And what you do is you take your ruler and you measure that distance exactly. That's more accurate than the key in the corner. The key is kind of generic. But we're going to use the key because that's what we have. So, okay, so we have 7 inches, 300 miles. So let's say I want to start in Des Moines, and I want to go to a major city. Let's say I want to go to, let's go to New York, right? Straight line, straight distance to New York City. Here's New York City, on the line. There you go, straight between Jersey and New York. So I want to go there, straight line distance. So the idea is what you do is you use this scale, and you just measure it on the map with your ruler. So New York to Des Moines, right? That is 23 inches exactly. So it's 23 inches. And what we do is we solve the whole proportion, and it tells you exactly how many miles that is. So you cross multiply and divide by 7, and this will tell you how many miles, because miles are on the bottom. So anyone with a calculator, please, can you do that? 23 times 300, and then divide by the 7. What is that in terms of miles?
328 miles.
328? There's your way there.
It's 6,900.
Whoa, not 6,000.
980.
23 times 300 divided by 7?
928.
Say it again.
985.
Okay. Is everyone getting that?
Oh, yeah.
Oh, yeah. All right. Now, why I know that? It only takes 24. It's 2,400 miles, so 2,400 miles to get from Washington to San Francisco. So when you said 6,000, I'm literally in like France across the world. It wouldn't be 300 because 300 is this far. Like this is 300 miles. To get to like Fort Wayne, get to Indianapolis and stuff. 300 miles. So I can kind of guesstimate with my fingers. So 900 miles, that makes sense to me. So, if you know how far your car can travel, newer cars, like my car tells me exactly how many miles I can travel roughly with my tank. It says 320 miles. So I know I'm going to have to fill up a couple times. 3 times maybe, before I get there. Maybe 4. This depends on how fast I'm driving, how slow I'm driving, how many stops and starts I take. So it gives me sense. Like I know how much gas I'm going to use. Whole tanks of gas. So I got to know, okay, it costs me $30 to fill. So I might, guesstimate how many times it will take me to get there. It might take me, $90 to drive in New York City as opposed to flying there. That type of thing. So, but that's what my father used to do. I mean, this is an old school way of doing it. But it is perfectly made for this. I'll show you like in a later time, how we can guesstimate fuel and how we can guesstimate time it will take. But right now, this is perfect. This works out great for how this works. All right, let's go to a different town. We're going to use the same 7 over 300 because that's what my map says. But let's pick 2 different towns now. So what are 2 major cities you want to talk about?
Las Vegas.
Las Vegas. And where do we want to go from Las Vegas?
Miami.
Miami, Florida. All right, that's good. All right, we'll do those 2. We'll figure out the distance. Now, this is straight line distance, not roads. By the way, this is like an airplane flight. But it gives you usually kind of like a guesstimate what the numbers are going to be. Now, obviously, if you type in Google, it'll give you the directions and it'll be a little bit off. But all right, so Las Vegas to Miami. I can't even get a straight line. So, all right, so this is 36 inches exactly, and we got to go a little more. So 36 plus 13. Okay. 13 inches. And that was a total of 36 inches. Around here, there, further. All right. whole stick plus a little bit extra. All right, so how many miles will it take me to fly there? So we're doing the 49.5 times 300 divided by 7. And this should be a lot longer. We're going way longer distance.
21.
Say it again?
21.
21, 21?
Yeah.
Is that what I'm getting?
Yep.
Okay, that makes sense. The reason why, we nearly crossed the entire U.S. to go. Okay, the U.S., the entire U.S., like straight across is 24 miles. We nearly did that, so it makes sense. Okay? So it's a perfect scale. And why this is important. You can guesstimate, fuel. It's going to take you time to drive there, because maybe it's just cheaper buying the ticket than actually trying to travel that far in a car. It takes a long time, it takes what? From here to go, from here, this is Mason City. To go to Des Moines, it takes roughly 2 hours. So, that's 2 hours, 2 hours, 2 hours, 2 hours. And you can kind of guesstimate how long it would take you. So if this is 2 hours, then you can kind of guesstimate hours. Okay, that good thing. Now, airplane flights, just to let you know, this is a weird quirky thing. As you go from west to the east coast, it's actually faster than going the other direction. The reason why, you jump on the jet stream. So the jet stream is this level of clouds where the speed is actually faster than the wind speeds on the ground. So they call it jet stream. Jets interrupt the stream of air, and it actually carries the plane faster from the west coast to the east coast. If you go backwards, that's why planes, as they go from like east to west, they're lower in the sky. They have to avoid the jet stream because it actually slows them down. So that's just a weird, quirky little thing. So this flight was actually really fast. We started in Las Vegas that night, as opposed to the other direction. Okay, now, any questions with the proportion of them? Now, what we're doing here, what I'm showing you is literally an airplane distance. Straight, linear shots. Not taking roads. Because if you actually search in Google, that's the part that I was talking about. Like, you guys have so much modern technology and phones anymore that you can guesstimate down to like the nearest minute how long it would take you to go there. Because your phone will show you the driving path to get there. And it'll say, it's 2,600 miles or something. Yeah, because you're zigzagging your way across the U.S. on a road. Okay? So that's the idea. But, this is kind of fun that you can kind of guesstimate that. What we're going to be doing tomorrow is I'm going to be giving you 6 challenge questions. What's the distances between these certain towns? And I'll give you the scale. I'll give you the scale like a corner or something like that we're going to use. And I want to see how close to the distance you can get to those. And then we're going to do something completely different tomorrow. We'll do something a little bit opposite than what we're doing here. Okay, and it'll be kind of fun. Alright, today, page 61, 62. If you have not turned that in, that is due tomorrow. So you got to make sure that you're working on it. I'll go through the names of who have actually turned it in. Okay, perfect. Jason, see who else. I got it from Cole the other day. I don't know where he's going. I got it from Sean the other day. Jason, I don't know if you're turning to page 60 to 63. That was fine. I don't need to do it last Thursday. I don't have that one. Sean, did you do that? Wait.
Yep.
The pre-calc or the
Yeah.
Probably wouldn't be
So
there.
Alex, you already have this one turned in, I believe. Yeah. Thank you. Is that the one from last week or is that this week's?
I thought it was Monday. So I do it all.
Yeah. So Alex, I got yours. Page 61.
Wow, that is crazy.
How far of a distance is that when you drove?
In a car,
Yeah.
$36.
But how many miles is it? Because it's way longer than 21, 22.
2,520.
Extra 400 miles. Just driving. Then you have the airplane distance as well.
Yep, airplane at 4 hours and 30 minutes.
It's like, that's crazy. That's going from Vegas to Miami.
Yep.
Yeah. What about the other way around? Can you type that in?
Yep.
Because that was 4 hours and what, 20 minutes?
30 minutes.
30 minutes. All right. So now type the other. Type Miami to Las Vegas, and you can see it's the same distance, but traveling takes longer on an airplane because that jet stream thing slows them down.
Yeah, it says 5 hours and 15 minutes.
Yeah, there's no difference. The same 2 towns, but going the other direction slows them down.
What was the other time?
4 hours and 30 minutes versus almost a full hour longer going the other direction.
That also makes sense because when we were going to DC, when we were flying into DC, we were an hour early.
Yeah, hour early. Yeah, because the jet stream speed your plane up as you go, it's pushing your plane faster. So this is a weird little quirk thing. People don't think about that. That's why it's easier to fly from like New York all the way to Europe versus going the other direction. They usually bounce you around a little bit. The jet stream slows you down a little bit.
Just like driving in the wind.
Yeah, literally. It slows you down. It drags. That's why you gotta pick the days when you know it's not gonna be windy. Especially like if you're driving, you almost have to worry about it too when you're in those like areas like Arizona or Wyoming or those areas where there's just large open ground and there's no gas stations for miles.
Yeah.
You have to fill up when you see a gas station, not when you think nothing.
That's when, like, you see a town, you look at it, oh, I'm going to have to take up fine.
Yeah, you fill
You
up.
want to fill up.
And the worst part is, on certain cars, they literally tell you, like on certain trucks, you cannot go to the next town. You have to take a fuel with you. Like with my truck, the truck that I drive here on certain days, it's 6 miles per gallon. Tops. And like, I can go to Des Moines, there's already 3/4 my tank. And then I'm going back to even worse.
Oh, my Uncle Kyle, he was coming back from Des Moines, and he didn't stop, thinking that he would be fine. And gets like kind of by outside of Belmont, and his truck said to him, increase speed, because he was running out of fuel.
Yeah, that's weird. You have to increase your speed because you get better fuel economy. You have to go to, like to get optimal range in cars, you have to be between 55 and 62-ish. That's where you get your optimal gas consumption, which is weird. It's like, the idea is like, if you're to drive around the lake, just take a lake lap in your car going 25 miles an hour. You'll burn half a tank of fuel, as opposed to just traveling that same distance at 55, you wouldn't even use a quarter of a tank. So it's just this weird little thing that cars have spinning.
Yeah, bro, you know when we were on the plane from Minneapolis to DC, it took us 2 hours and 20 minutes. And when we went back, it took us 2 hours and 35.
And it probably felt longer too.
And it
So
Yeah.
how many stops you take.
We were going back for like,
yeah, can this stop?
we got home at 10, wake up the next day and go to school.
Yep,
Awesome.
we got back on a Tuesday. Like, ugh.
That sucked.
I didn't want to go back to school. Like, I want to stay home. One of those things.
Yeah.
Of course, sleeping on a plane is not easy.
Oh no. Not 10. We got it at 29, right?
Yeah, I know. But I would do that again, but you know, not. I would go back to DC again.
Oh yeah.
Because then we won't be on a schedule.
Actually, I like those.
Well,
Sometimes.
at least we have more time to like explore the whole. Like that golden, where we, what's that place going? I can't think of the name. That was good, but they're, ugh, I didn't like the price. Way over.
Yeah. We're kind of like the test dummies.
Well,
We're going through
Maybe closer
previous because
the lighting.
what do you guys like the best? So we're like,
Have a good one.